Hey everyone, I am Nitij and today we will discuss rate limiting and its importance when it comes to APIs and how it plays a crucial role in server stability and efficiency. So, rate limiting is a control mechanism that restricts the number of API requests a user or service can make within a specified time frame. It is essential for preventing server overload, ensuring fair usage of resources, and protecting against abusive traffic like the ones which are called as distributed denial of service attacks. So, how does rate limiting works? Rate limiting involves setting a maximum number of allowable requests over a certain period, example per second, minute, or hour. So when this limit is exceeded, then the API typically responds with a 429 status message, which is for too many requests. And there are some strategies which include simple count limits or more complex ones like the leaky or token bucket algorithms. So what are the different types of rate limits? Well, there are primarily three types. The first one is the user level limiting, which simply targets individuals or users' IP addresses to prevent abuse from a single source. Then there is the application level limited. It imposes limits on the API key, so it is based on the specific application making the requests, which is usually identified by the API key. The third one is the server level limiting. This one establishes a global limit for all incoming requests, ensuring overall server health and performance. This primarily depends upon the server's capacity and makes sure that even the requests of legitimate users does not overload the server beyond its capacity. Now let's talk a little bit about the implementation techniques, which covers how rate limiting can be implemented in our API backends. So first, how rate limiting is communicated between the server and the client, and that is by means of HTTP headers. So X rate limit, limit, and remaining and reset. These are the primary headers which are used when it comes to server-side implementation. Then server-side middleware can be employed in web frameworks to seamlessly integrate rate limiting, which enhances security and efficiency. So this is VS Code, and I have created a very tiny API backend using Node.js. Now the important thing to note over here is we are creating a backend app using Express, and then we are also importing the Express rate limit package. So Express rate limit package can be used to limit the rate at which our API backend serves the incoming requests. So we define the window ems, which is typically the duration in which we have to count the maximum number of requests. Max is the maximum number of requests which can be entertained, and the message is if the request is breached or if there are too many requests, then this message will be returned with the response. And this API limiter middleware is being applied to all the API requests. And for the demo purpose, we have created a root with the name API, and the server is running on 3000. Now let's test how this is going to work. So this is Postman, and I am going to send the request one by one. So this is the first time which says welcome to the API, which is the message we are meant to receive from this API root. Now let's send the request again, third time, fourth time, fifth time. Now let's send the request for sixth time. This time we get the message too many requests from this IP, and let's check the actual headers. What are the headers that we are receiving? So the X rate limit header value is 5, which is the value that we have used for maximum number of tries before which we are logged out for a particular duration. This is the remaining. Now after we have breached the limit, the remaining number is 0, and this is the reset. So this simply shows the time when this is going to reset. So this information can help the clients to know when they will be able to again make the request to this API where the rate limiting has been applied. So after this small demo, let's talk about the benefits of rate limiting. So rate limiting is vital for managing server resources equitably, which simply means enhancing security by mitigating abuse and attacks, and contributing to the stability and reliability of our APIs. It also helps to maintain a high quality of service for all the users. There can be several challenges and considerations when it comes to applying rate limiting. So, setting appropriate limits requires balancing user needs and server capabilities. Ensuring that rate limiting scales effectively with application growth is crucial to the user's satisfaction. It's also important to consider how rate limits affect user experience and to implement them without causing any unnecessary inconvenience. The best practices about rate limiting is clear documentation of rate limits, which is essential for transparency so that everyone using the API know what are the limits applied to the API requests so that they can handle this limit in their clients appropriately. There should be graceful responses to exceeded limits, which can help maintain a positive user experience. And then there could be adaptive limits which adjust based on real-time usage patterns. This can optimize both server health and user satisfaction. So finally, what are the future trends of rate limiting? There can be advanced techniques like AI and machine learning, which are being explored for dynamic rate limiting, which can predict and adjust limits in real time. Cloud-based solutions also offer scalable and robust alternatives for handling rate limiting across distributed systems. And that was everything about understanding API rate limiting. It's all about finding the right balance to ensure optimal performance without hindering user experience. Keep an eye on how we handle requests exceeding the limit, ensuring our server gracefully manages these situations. If you found this tutorial helpful, then don't forget to hit that subscribe button. I regularly post content that helps you stay on top of your coding game. Thanks for watching.